Okay, so guys, getting ready for our quiz on Friday. What I think you need to be really solid with, you need to know all 6 of these trig functions. Okay? What is that? SOHCAHTOA, what does that mean? The sine is what? Yeah, opposite over hypotenuse. What is the cosine? Yeah, adjacent over hypotenuse. What is the tangent? Yeah, opposite over adjacent. Okay, you got to be solid with that. If it takes writing that down at the top of the quiz, you're good. Okay, now there are 3 reciprocal functions. Okay, what's the reciprocal function? I always start with tangent. What's the reciprocal of tangent? Cotangent. Okay, it shouldn't be too hard to remember. Tangent and cotangent go together. You guys got a way to remember that? They both have the word tangent in them. Okay, they go together. So what's the definition of cotangent? Adjacent over opposite. Now, I don't ever remember that. I just know that if I can remember what the tangent is, I know the cotangent is reciprocal. So I don't worry about memorizing the reciprocal functions. If I can memorize which one goes with which. What's the reciprocal of the cosine? Was not a trick question. What's the reciprocal function for the cosine? It's which one? Secant, okay? So the secant is the reciprocal of the cosine. Well, if the cosine is adjacent over hypotenuse, this is just the hypotenuse over the adjacent, okay? And then what's the reciprocal of sine? Cosecant. So that's going to be the hypotenuse over opposite, okay? Now what you can remember is when you pair up these reciprocal functions, you only see one C, one of them starting with a C, okay? You never have cosine and cosecant together. You never have 2. So you always have tangent and cotangent. One of those starts with a C. Cosine and secant, only one of those starts with a C. Sine and cosecant, only one of those starts with a C, okay? So that's one way to remember it. You've got, like I said, S and C, T and C. So there's only one C or one co-function in each of those pairings, okay? Like I said, if you ask me the secant, I can probably not tell you that it's hypotenuse over adjacent. I just look at the secant, that's the reciprocal of the cosine. I know what the cosine is. So I just memorize those first 3 and then know how they pair up with the reciprocal functions. But however you get there, you've got to bring this knowledge to everything we do. And you've got to know this for all these right triangles, okay? Now what we're going to do in this section is we're going to do some word problems that each of these is based on right triangles, okay? So your job will be to read the word problem and then draw a model based on a right triangle. So each of these word problems is going to beg you to draw a triangle, and that's your key to getting this thing solved. Now there comes some terminology you'll need to know. One is called an angle of elevation, okay? So let's look, for example, here you are at the bottom of this building, and there's something at the top of a building. It doesn't matter, it doesn't have to be building, but there's a reference point that is lower than something else, okay? So what we call the angle of elevation is normally, if I'm standing and I'm looking, I'm going to look out and I'm going to see which direction. If I just look steady, which way will I be looking? Straight, up, down, what? I mean, normally if I'm standing here, I'm just going to look out straight, okay? To see the top of the building, what do I have to do? You have to look up. So angle of elevation means like normally I would be looking straight ahead, but in order to see the top of the building, I'm going to have to look up. The angle at which I have to turn my head or my eyes or whatever, that's called my angle of elevation. So this is my angle of elevation. And you can see that that forms a right triangle. If I were at the bottom of a building, if I went straight ahead, that's the base of the triangle. And then if I look up, that's going to be, this is called the line of sight. So it's where my eyes are. But in the triangle, what is this? What's this side right here? It starts with an H, hypotenuse, okay? So anytime you have a word problem and you see the terms line of sight, which side of the triangle are they talking about? The hypotenuse, okay? So this is a problem when they deal with angle of elevation. Now, there's another concept, the angle of depression. Now this is just sort of doing the problem in reverse. I'm up on top of the building, okay? If I look straight ahead, You know, I look out and I see the athletic building there. But if I needed to see the sidewalk, what would I have to do to see the sidewalk? I would have to look down. Okay, so normally I want to look straight ahead, but in order to look down, I have to do this. So that the angle at which I look down is my angle of depression. Okay, so the angle of only difference between angle of elevation and angle of depression is the reference point of which thing is higher. So if you are higher, and you're looking lower, it's an angle of depression. If you're lower looking higher, it's an angle of elevation. So if I would look straight out, here's an angle of elevation. This is my line of sight. In that triangle, the line of sight is what side of the triangle? The hypotenuse. The line of sight is always the hypotenuse, okay? And so you'll need these in order to work on these problems. So these are just some concepts that will be in the word problems we're looking at. So let's go ahead and get started. So one of the keys in each of these is you have to draw a triangle. If you're of the mind of trying to work these problems without a triangle, you're going to miss it, okay? So the big key in each of these is to draw a model of what you see and then go work on the triangle, okay? You're standing 100 feet away from the Woodward Library. The angle of elevation from your vantage point to the top of the library is 38 degrees. How tall is the library? Okay, so each of these models is going to be a right triangle. Okay, so let me just draw a right triangle. Now, based on the description that you see there, can I label any of the sides or any of the angles? Yeah, so this is my library right here, okay? So what does the 100 feet, what does that correspond to in the triangle? It's the which side of the triangle? The bottom, okay? You're standing 100 feet away from the library, so it makes sense that that is 100 feet, okay? And then what is this 38 degrees? Right, so it's the angle of elevation looking up to the top of the library. So this is 38 degrees, okay? So I've used all the information that was given me in this word problem. Now, what question are they asking? How tall is the library? Does that correspond to anything in my triangle? Which side did that correspond to? So how tall is the library is which side of the triangle? It's this one, okay? So now I've got so the diagram is all correct before I do any trig. So I've got, this is how far away from the library I am, this is the angle of elevation, this is what I'm trying to solve for. Now, if I look at this angle right here, 38 degrees, now you have to investigate what sides do you have. Relative to this angle, this is the what side? Opposite. So I've got, this is the opposite side. Relative to this angle, this is the what? Adjacent side. What trig function deals with opposite adjacent? The tangent. So I know that the tangent of 38 degrees in that triangle, what does it have to equal? So what's the opposite side? X. What's the adjacent side? 100. So here's my equation that I have to solve. The tangent of 38 is x over 100. How do I solve that for x? And multiply by 100, so x is equal to 100 times the tangent of 38 degrees. Anybody off the top of their head know that one? Nope. So you go to your calculator. 100 times the tangent of 38, and that is 78.13. So in the context of my problem, I don't leave it like that. How do I answer this problem? The library is what? So the library is 78.13 what? Feet tall. So make sure your answer has numbers and words And if there are units, make sure the units are there. Okay, so there's not a lot of difference between what we did yesterday once we got to the triangle part. You know, if I gave you this angle, you didn't know this side and you knew this one, you could know that the tangent was the function that makes that happen. But the key here is you've got to look at the word problem. You've got to draw the diagram. Once you get the diagram, look at which sides you know and which trig function is going to help you model that. Okay, so let's look at another one. The keeper of the 144 feet tall Tybee Lighthouse looks down at an angle of depression of 6 degrees to a spot on the ground where he sees Little Honey Boo Boo. How far is Little Honey Boo Boo from the base of the lighthouse? Do y'all even know who that is? So, okay, it was popular maybe 7 or 8 years ago or something. You know, a train wreck of a TV show, whatever. So, I mean, you don't have to be really a fancy drawer, but you know, I've got a lighthouse here, something like that. Okay, so the lighthouse. Okay, and so if I'm looking out, where am I going to spot this person? Will I be looking up or down to find this person? Down. So Little Honey Boo Boo is on the ground over here. Okay, so that means I am looking this way. Okay, so what that means is this is my drawing. Normally I want to look straight out, but in order to see Little Honey Boo Boo, I have to look down. So what is this angle right here? What angle is 6 degrees? Angle of depression. Normally I want to look straight, but I had to look down. So this is the 6 degrees right here. Normally I look out, but if I do a 6 degree depression, I look down. This angle is 6 degrees, okay? Now what else do I know? Okay, does that correspond to one side of my triangle? Yeah. So that means that this has to be 144, okay? And what did they ask me? From the what? So they're asking me, like, how far is, this is the base of the lighthouse, how far is she away from here to here? Does that correspond to one side of my triangle? Yeah, it's which one? It's this side right here, okay? So now I've got an angle, okay? What is this side here in my triangle? Is this the what side? Yeah, so this is the opposite side. What side is this? Adjacent. What trig function will help me deal with opposite adjacent? It's the what? The tangent. So I know that the tangent of 6 degrees is equal to what? What's the definition of tangent? Opposite over adjacent. So it's 144 over x. If I multiply both sides by x, I get x times the tangent of 6 equal 144. How do I solve that for x? Pardon me? Right, divide by tangent of 6, so you get x equal 144 divided by the tangent of 6 degrees. So in my calculator, so it's just 144 divided by trig function, tangent of 6 degrees, and I get 1370.07. What does that mean in the context of my problem? Yeah. Yeah, it means that Little Honey Boo Boo is 1370.07 feet away. That sounds like a safe distance, I guess. So each of these problems is set up with a right triangle. So your goal, you have to be able to draw a right triangle that models the equation and then look at what you know. And what you know will tell you what trig function to use. Now, why could I have not used the sine here? What's the definition of sine? Opposite over hypotenuse. So that would have given me this. If the question had been, what is the line of sight distance from the lighthouse to Honey Boo Boo? That would have been this side right here. Okay, the line of sight is always the hypotenuse. But I didn't ask for the line of sight distance. I asked for the distance from the base to Honey Boo Boo. So I asked for the adjacent. So if I had been asking for the hypotenuse, you would use the sine function. Okay? So the Empire State Building is 1,250 feet tall. If at 5 o'clock the building casts a shadow of 5,000 feet, what is the angle of elevation? Okay, so you can draw your favorite Statue of Liberty, not Statue of Liberty, Empire State Building. So there's the Empire State Building. And now, where are shadows? Where do you find shadows? On the what? Oh no, on the ground. The shadow is on the ground, right? So I know that. How tall is this building? How tall is the building? So the building is 1250. Its shadow will be on, where will I draw the shadow? On the ground. The shadow is on the ground, okay? So I've got something like this. And how long is the shadow? 5,000, okay? So the building is 1250 tall. The shadow is on the ground. You can see this is my right angle. They're asking me, what is the angle of elevation? Which of these angles are they asking me for? Are they asking me for this angle or this angle? Okay. Angle of elevation. What's the definition of angle of elevation? You're lower and you're looking what? Up. So this is the angle they're asking me for right here. The angle of elevation. So they're saying, hey, where that shadow hits, what's the angle of elevation that you have to get to look up to the Empire State Building? Okay? So now what do I know? This angle, relative to this angle, what is this side over here? That's opposite. What is this side over here? What trig function would deal with that? Tangent. Okay, so I know that the tangent of theta is equal to what? Yeah, so 1250 over 5,000. Okay. Now I need to solve that for theta. Theta is the what? It is the, what is it in this thing? The angle. So how do you solve for an angle? We did this yesterday. Pardon me? No. You have to take the inverse. So in order to solve this, I have to take the inverse. Which function? Inverse of what? Inverse tangent. So anytime you solve for an angle, you have to use the inverse function. So to solve for theta, I know that theta is equal to the inverse tangent of 1250 over 5,000. So the inverse tangent of 1250 over 5,000. So I'll come over here and just say trig function, inverse tangent, 1250 divided by 5,000, and that is 14.04. So what does that mean? Right, so the angle of elevation is 14.04 what? Degrees, okay? So this one was different. We still use tangent, but in order to solve for the angle, you have to use the inverse trig function to do that. Okay, we're doing okay with this? Questions? So again, there's not a whole lot new, It's just that they're wrapped up in the complexity of a word problem. And you've got to be able to draw the right triangle diagram and then know your trig functions in order to get that solved. Yeah, a few more and we're done. So New York City's Freedom Tower stands at 776 feet tall. Does anyone know why it's that tall? Come on, guys. What does that number mean? That's the founding of America, 1776, okay? So the Freedom Tower is 1776 feet tall. As you fly your new Learjet towards the Big Apple, you notice the angle of depression from the plane to the tip of the tower is 28 degrees. And the line of sight distance, line of sight will correspond to what side of a triangle? Hypotenuse is 5,000 feet. Okay, what is the plane's altitude? So you've got to draw your diagram. So you've got a building. Okay. Will the airplane be higher than the building or lower than the building? We are hoping that the airplane is higher than the building, that this is not 9/11 reenacted. So we are hoping the airplane is higher than the building. So we've got an airplane over here. So I can see if I can draw an airplane, something like that. So you've got an airplane that is flying toward, okay? So what do I know about how tall is the building? Yeah, so I know that this is 1776 from here to here, okay? And then what do I know about the relationship between the plane and the building? Yeah, so the plane is looking down on the building, okay? So normally the plane would be looking straight ahead, but it's looking down and it's looking down at this building. Okay, so this is the angle of what? They called it the angle of depression. That means the plane is higher than the building, okay? And then what do they tell me? What other pieces of information can I fill in on this triangle? The what? The line of sight. So which of these sides is the line of sight? Which one? Yeah, so that's 5,000. That's the line of sight. So the plane normally is looking ahead, but it looks down and it sees the top of the building. And then what is this angle right here? Yeah, this angle is 28 degrees. So normally the plane is looking ahead, but we're told that it looked down 28 degrees, and that's when it saw the tip of the building. Now, what are we trying to find? The altitude of the plane. So which side will help me know that? This one right here, okay? This is the side I need. When I find that side, will that be the altitude of the plane? No, it will be the altitude, and I have to add what to it? 1776, okay? So here's the angle that I know. What side is this relative to that angle? That's the opposite. What is this side? Okay, which trig function deals with opposite and hypotenuse? The sine. So I know that the sine of 28 degrees is equal to what? Yeah, x over 5,000. And then how do I solve that for x? Yeah, x is what? 5,000 times sine of 28. And where do I go to find that number? Yeah. So 5,000 times trig function, sine. Was it 28? Was it 28? Okay. And that is 2347. I'm just going to round it off. I'll just call it 2347. So x is about 2347. 2347 what? Feet. But the plane, so the altitude of the plane is going to be what? Yeah. So the altitude of the plane is going to be 1776 plus 2347. Is that right? Or is it 40? Someone do that on the calculator. 3, 1. I think it's a 4. Did someone check me on that? 41, 20, 1776 plus 2347. Okay, 4123. So the altitude of the plane is 4123 feet. Okay? So the key here is, like I said, drawing the diagram, getting everything labeled appropriately. Then what's the next, after you've got the diagram, is to determine which trig function to use. That comes from looking at the triangle and looking at what you know and what you don't know. Okay? So there is a tree that is 50 feet from your house. You know that the angle of elevation from the ground at your house to the top of the tree is 39 degrees. If the tree falls, will it hit your house? Okay? So I'm going to draw, here's my house. Okay? And then what do I know about this tree? It is 50 feet away from my house. So I'm going to come over here 50 feet away, and that's when I have this tree, okay? So the tree is 50 feet from my house, okay? Can you see where am I going to draw the right triangle? So what is the angle of elevation is from where? What does it tell you the angle of elevation is? From the where? From where? Yeah. So is the angle of elevation over here or over here? Which side is it on? Is it over here or over here? It's. Read what it says. Is the angle from where? Well, no. Read what it says. The angle of elevation is from where? From the ground to the top of the tree. The angle of elevation starts here, and it looks up to the top of that tree. So this is my triangle. So it's telling me the angle of what if they said the angle of elevation is from the bottom of the tree to the top of the house? Then your triangle goes this way, okay? But they told me the angle of elevation is from the base of the house to the top of the tree. So this angle is 39 degrees, okay? Now they're asking me if the tree falls, will it hit the house? What do I need to know in that diagram to know whether or not it hits the house? Right, the height of the tree. If the height of the tree is greater than 50, then what? It hits the house. If the height of the tree is what? Less than 50, it what? Does not hit the house. So I'm being asked to find this side over here. Okay, so here's my angle. What's this side? This side is the what side? Opposite. This side is the what? Adjacent. We're using this trig function a lot today. Which one is it? Tangent. So the tangent of 39 is equal to what? X over 50. To solve that for x, you get x is equal to what? 50 times the tangent of 39. And then I just go to my calculator. So 50 times trig function, tangent 39, and that is 40.49. Yeah, so that represents how tall the tree is. So what was the question? If the tree falls, will it hit the house? So no, it will not hit the house because it's 40.49 feet. Okay, so a tree that's 40.49 feet, when it falls 50 feet away from a house, will not hit the house. Okay. Now, what's hard about this? What's challenging? Okay. So it just takes time. You've got several word problems to work through on this section. Just keep in mind every one of these is a right triangle. So you've got to draw a right triangle, otherwise you won't be able to solve it. And just keep in mind, angles of elevation start low and look up. Angles of elevation say instead of looking straight ahead, you're looking down. Okay, so that makes it, if this is your right triangle, the angle of elevation is sort of that triangle is going to be upside down when you do the angle of depression. Okay, let's look at another one here, and I think we're good after that. Woodward Academy has decided by placing a slide on the top of Woodruff to the base of Moss, students can get to math classes much more quickly. So if Woodruff Hall is 110 feet tall and the safe angle for a slide is 34 degrees, how long should the slide be? Okay, so you've got two buildings. I mean, it doesn't really matter. You've got, so here is, we'll draw Woodruff Hall over here. Like that. There's Woodruff Hall, and then somewhere over here is Moss Hall. It's not important that you get these correct, and you can tell. Although, Margaret, I hear you're the artist, so you should be, yeah. So you should be able to do this much better than I am. So we're putting a slide. What does a slide do? I mean, does a slide go this? How does a slide go? Yeah, it goes down. So the slide is going to go from Woodruff to Moss, okay? Can you see how I'm going to make a right triangle out of this, okay? So what do I know in terms of the numbers now? Where does the 110 go? So 110 corresponds to what? In the problem. How tall Woodruff? So which side of the triangle is that? Yeah, the right side. So this is 110, okay, from here to here. And then what is that 34 degrees? Which angle is that? No. When you measure an angle of a slide, angle of a ramp, you measure it from where? From the bottom. So this is 34 degrees down here. When you talk about a ramp being 45 degrees or 34 degrees, you measure it from the bottom. So now I've got an angle. Relative to this angle, what is this side over here? This is the opposite. Now, what are they asking me for? They're asking me what? How long the slide should be. Which of these is the slide? Yeah, so this one, that's the hypotenuse, okay? What trig function deals with opposite and hypotenuse? Sine. So the equation is what? Yeah. Sine 34 degrees equal, 110 over x, okay? So I know the opposite side, I know the sine, I know this is a sine, and I don't know the hypotenuse. To solve this for x, you multiply both sides by x, you get x sine 34 equal 110. And to solve that for x, I get what? X equal 110 divided by sine 34. So if I put that in my calculator, 110 divided by trig function, sine of 34, and I get 196.71. So that tells me that the slide is 196.71 feet. I'm not sure that it's a high priority for this school to put the slide in. So, anyway. Wouldn't it be nice? A zip line, I think, would be better. Wouldn't it be fun? Wouldn't it be fun to have a zip line that you can just do that? There'd be people dropping book bags, all kind of stuff. It would not be so hot. Okay, so guys, here at the end of this, the big thing at the beginning was this angle of elevation, angle of depression. Angle of elevation means the vantage point is lower looking up, and that creates an angle. Angle of depression means the vantage point is from up high. Instead of looking straight out, you're looking down, so it creates this angle between the horizon when you're looking straight and looking down. And then you have to be able to read these word problems, label the sides appropriately. Each of these is a right triangle. And then you just look at what you know. In most of these cases, you either know an angle and a side or two sides, either way. And you have to know the relationship. If you know opposite and hypotenuse, you use sine. If you know adjacent and hypotenuse, you use cosine. If you know opposite adjacent, you use tangent. So knowing which sides of the triangle you are given tells you which trig function to use. Okay?